Hi guys, I'm back with another topic here, basically final submission or pipeline here. So the reason why I'm doing this is in the production environment, we do not pass the entire test data which is featureized. Rather, we pass the original test data, either whole data or single point. Let's say we are passing this one single point. So in this, when we pass, we have to featureize everything accordingly. Let's say for dates, if we have to extract the year, month, day, hour, minute, season, whatever, right? So we have to extract. It can be extracted with simple functions. And coming to this day of week, we have to encode with respect to other days, right? One hot encoding basically. And same goes with the PD district. And for address, we have to implement bag of words, TF, IDF, and get all the features. And for X and Y, basically latitudes and longitudes, we have to extract features like distance-based features, uh, arithmetical operations on coordinates. So everything we have to extract. And this has to be done for the original data, original test data. In production, we do not pass the featureized test data. That's the only problem. So to avoid that, to solve that problem, we come up with a final pipeline approach wherein we take a single point and try to get all the features for that point. So this is my XQ, which is a single point, basically query point. Okay. And this is the helper function. And this class is nothing but how we can featureize the time variable or dates here. So let's say we are passing single point. That becomes my self.xq, and we will be extracting date, year, month, day, hour, minute, season, hour type, time period, and address type. So all this can be extracted uh, by checking the dates and the address. Okay. And then we featureize it in such a way that all the values that we just obtained are in one single row. So this is the following, this is the function or method that it will take care of. And finally, we are returning the transformed data frame, TDF, by renaming the columns and combining everything into one row. That is done for dates and the address type. Next is one hot encoding. So for one hot encoding, we also go with the same approach. So here the categorical features are being encoded into one hot encoding type. So as usual, we take the query point and we make it global variable. And there are some values with which we can take care of one hot encoding. And here I have the methods encode into OHG. So it will give me the result wherein it has to put one for the index where it matches and the rest of the indices are 0. So this function is very much helpful for that. And get dummies is another method by checking the Bay Area. It will make sure to give 1 when the value is matched. Otherwise, it is 0. So this is taken care here. It takes care of it. It considers this list, police regions. And similarly, for days, same concept is been applied here. If it is Friday, it gets the index of that and assigns 1 to it. Otherwise, 0. Similarly, for time periods, that is AP, AM or PM. So only 2 values, so only 2 conditions. And for seasons, we use self.seasons and we check the index value, and if it matches, then we put 1, otherwise zeros. Same concept we also apply for this part, that is our type. And finally, we also apply to streets. Since streets can be more, I have just used for loop and applied this technique. I'm using this method called self encode OHE, which is this method basically, and it gets the one hot encoded values for it for each point in it. And after getting all that, we must combine everything and get the single row, right? And this is the final approach that I'm following: transform data frame. So this is only for one hot encoding class. And similarly, we have to also get for spatial distance features. So the same concept we will be using, but in this query point, we must ensure that we have coordinate values to actually find the distance and get the single row finally. And later on, we also use arithmetical operations to get the lateral on features. Same functions have been used that we have taken, that we have looked in previously. And in this final method, we also take a simple approach of converting everything into one single row. And next is a back of first representation and the TF-IDF representation. So here we also remember we have saved the models of the transform vectorization, right? So we'll be loading that and we'll be transforming it for the single point. And after doing it, we also select the best features, right? So this is the approach to select the best features. Actually, these are the features which we got from the previous methods. In the sense, when we use the select k best approach, we passed k equals 20 to get the 20 best features, right? For out of 2000. So the column names. So this is the column names that we are getting finally to get the best features. We'll be combining everything and as a single row and returning that as a final value, transform data frame. And once we get it, we also take labels separately. And this is the final pipeline, basically single point predictor, which takes all the classes which you have defined earlier: address features, lateral on features, spatial distance features, and one hot encoding, and also time based features. So we'll be using all those classes into this final pipeline, that is crime classifier. So we'll be getting all the rows, and once we get everything, we finally combine them into one single row and then pre-process the same. And once we pre-process, we can easily predict the classification point by loading the models whatever we want. And these are the if conditions to load the model which we want based on the model name that we pass. And once we load the model, we can get the predictions, and from those predictions we can find the maximum index value and get the actual label out of it. So this is the entire pipeline. And for testing purpose, if the query point is one of the rows in the test data, input equals xq. This is one of the rows in the test data, right? So we have time, Sunday, Bayview, and the address, and also lat long. After this, by calling the crime classifier class here, by making an object of that, we can simply use predict method out of it to get the actual class level. So cc equals crime classifier, prediction equals cc.predict. So once we get the prediction point, we can simply print. The category of the crime is vehicle theft for this point. Similarly, if we pass a random point, say 10th value or 10th row of the test data, we can follow the same approach and get the prediction out of it. The UI part is very simple. So these are the inputs that we are following, right? Time, Sunday, day view. So we can pass this as a form basically. And when we click on the prediction button, the prediction comes. So for the demo purpose, I'll be showing this video, which I have recorded earlier. So just give a couple of seconds to properly load. Here I have time, weekday, police district, address, longitude, and latitude. And since we have the coordinate values, we can easily map it on the map box plot. Now, if you change the points there, any of the points, and change the time also, we can actually see the value changing, the prediction point here in the bottom. If any of the value is missing, it directly prompts the error message here. It says, please check the input values once again. So until we fill it up, we will not be seeing the prediction point there. So this is the entire pipeline. For your information, you can also check this link. And that's it for this video. And this completes our entire project. Thank you all.